Welcome to Transcended Institute. In this tutorial, we are going to solve some questions under vibration and waves. So I've got a number of questions with me here. The first question that we're going to solve is the question which is on the screen here, which is saying an object oscillates with a simple harmonic motion along the x-axis. Its position varies with time according to the equation. So the equation is x is equal to 4 meters cos open brackets pi times t plus pi over. So this equation which we have been given here is the one that we are going to be using. And immediately when you have been given such kind of equation, so meaning this is in a form of a cos theta times t plus phi. So phi is the angle adjacent to the actual angle. So now what is happening here is we have got A is the amplitude. Okay, so if we read the question, determine part A, determine the amplitude, frequency and the period. So the amplitude is A. So what is A here? So the amplitude is just 4 meters. You see, right? And then we also want to find the frequency. But before we find the frequency, I want you guys to understand that if an object is moving under simple harmonic motion, okay, if an object is moving under simple harmonic motion, then this is true. Velocity is equal to distance over time. But one thing I want you to understand is that for a simple harmonic motion to occur, the distance covered is the circumference. Or maybe, let me say, the distance we're talking about here is the 2 pi, which is going to be 360. Okay? So we say 3 pi, or not 3 pi, 2 pi divided by t. The time it takes to complete one cycle is the period. Now this velocity, when something is moving around the circle, it is the angular velocity. So then this is going to be like this. Okay? Over t. But I want you to understand that I can write this and say this is equal to 2 pi then times 1 over t, of which I know that frequency is 1 over t. So I can replace this with frequency. So I can say this is equal to 2 pi times frequency. This formula is very important for you to know it. I'll leave it there. Let me take back a bit to this equation. X as a function of time is given by A from the equation which have been given, which is A cos Wt plus phi. Okay? So now, if at all I want to find the frequency, from this formula, which we have just come up with, I can make F as a subject of formula because I have my W. My W is the number before T. So in this case, pi is my angular frequency, is my W. Okay? So in this case, this is just pi. So now it is in lads. Okay? So let's divide both sides by 2 pi, even here by 2 pi. So the frequency will be equal to this divided by that. So then frequency will be equal to, this is pi divided by 2 pi. So pi and pi can go. Frequency is equal to 1 over 2, which is 0.5 hertz. I want you to understand these things, guys. These things are very, very simple. And As long as you understand what is the principle behind each formula, it's going to be easy for you to solve the question. So the frequency is 0.5 hertz or 0.5 per seconds. Okay. What else are we supposed to know from there? We are also supposed to know how to find the period. So from this formula, I can make t as a subject of formula. So t will be equal to 1 over f. So the period will be equal to 1 over 0.5. So what is 1 over 0.5? 1 divided by 0.5, that is 2. So 2 seconds is my period. So you can clearly see that question 1, part A, I have solved it. Okay. So I'm going to be following the same principles, the same information which I've used for part A to solve part B. So we are saying that the period is 2 seconds, then the frequency is 0.5. The amplitude is there. Let's now get rid of this. Okay, the frequency is 0.5 hertz. Part B, calculate the velocity and the acceleration of the object at t is equal to, or at any time. So when you are trying to find the velocity at any time, we are just trying to find the velocity. So in this case, t we have not been given. Okay. So now to find the velocity from the first equation which have been given, you have to differentiate the function. So the derivative dy, so in that case we'll say if I differentiate this, I need to find the formula for the velocity. So differentiating this, you know guys, when we go back to calculus, if I want to differentiate cos, is negative sign. So in this case, I'll maintain a, then I'll say it will be negative. So that negative, I can just say negative sign. Okay. What is in the brackets here? Maintain it like that. So that phi, leave it the way it is. Then we do this has to come outside. Okay, so now the final will be v as a function of time, a times w. Okay, that is going to give me then that negative, let's bring it outside, so it will be sine wt plus phi. Now we can plug in the values. Vt, a is 4, w is pi, sine w is pi, t is just t, phi is pi over 4. So this is the answer for the first part. But they also say that we should also find the acceleration. To find the acceleration, then you differentiate now for the velocity. So acceleration as a function of time is going to be, what is the derivative of this? So it is cos. We keep this plus phi, but you do this now, it has to come outside. So it will be w times w, which is going to be a as a function of t, negative a w squared cos w times t plus phi. Now you plug in the values. In case you're having some challenges on how do we differentiate, let me give an example of how do we differentiate sine 2x. Sine 2x is cos 2x, then we do time the derivative of the angle. So the derivative of the angle is 2. So you do times 2, which is going to be 2 sine 2 cos 2x. So that's what I've done here. So the w is supposed to be multiplied it by outside. So you are differentiating wt. Okay. So in that case, we have this as a function of time. This is 4, so it's negative, then theta squared cos pi not theta but pi times t plus, that is pi over 4. That's the answer for the acceleration. Now again, using the result for part B, determine the position, velocity and acceleration. So using the information we have at part B, let's go ahead and do the calculation. So I'll start with the first one. The position when time is equal to 1, that is going to be 1 cos the pi times 1 plus pi over what? Pi over 4. What will be the answer? Let's see. As a function of 1. So now if I get my calculator, I can clearly see that if I do pi plus pi over 4, here I divide it by 1, so the common denominator is 4. But if I want, anyway, this is physics, it's not math, I'm going to use the calculator. I'll say pi plus open brackets, then again pi divided by 4, I close the brackets, so I'm getting 3. So this is going to be now 4 cos in the brackets 3.92. So I can round it off and say 3.93. Then now x as a function of 1. Now we have 4. Okay, we have 4 cos 3.93, which is negative 2.8199. So I'll say negative 2.82 meters. That is my position. Now again, using the second formula, we want to find the velocity using this formula now. So the velocity as a function of 1, we have negative 4 times pi sine, then this one it is pi plus pi over 4, of which we already know that this will be negative 4 times pi. This is going to be the same one which is here, 3.93. So what do we expect? I shift this formula to be here. So I expect to have the v as a function of 1. So now there I'm going to have negative 4 pi then sine 3.93. So I'm getting 8.91. That is positive 8.91 meters per second. That's my velocity. Now I can go ahead and also find the acceleration. You can pause the video, try to solve and compare with the answer that I'm going to find. Okay, so we can clearly see that acceleration as a function of 1, negative 4 pi squared, then you have got cos. So this one is going to be the same. It's the same thing. We are putting 1, so we are going to end up having 3.93, sorry. So acceleration as a function of 1 will be equal to negative 4 then pi squared. Now that is cos. So we have got cos then 3.93. So I'm getting 27. So it's 27.83 meters per second squared. That is the acceleration. E. So question 1D is saying determine the maximum speed and the maximum acceleration. So now I'll be using the previous information which I gave you guys. Now to find the maximum speed, from the formula that we have been given this. The first one I gave you, the one which we were given, actually it was it is in a form of this plus 5. So after differentiating, we say the velocity as a function of time, it will be given by this, but there will be negative. Phi. Then acceleration, it was this. Plus phi. Now when we want to find the maximum acceleration, the maximum acceleration from the formula here, direct, is given by, you just get this. So if you want, you can ignore the negative. That is not, there is no problem there, because remember, we talked about the maximum acceleration. If I take you back a bit, we said that the maximum acceleration from the formula, I think if you have forgotten, I can drive it for you. We know that F is given by negative kx, and at the same time force is given by mass times acceleration. So make A as a subject of formula. We'll have A being equal to negative kx divided by m. So when we're talking about the maximum, meaning x is equal to A. So therefore the maximum acceleration is given by negative k over m times A. But in this case, I don't have k, I don't have m from the data that we have. Now, if I don't have those things, what else can I do? I also know that this is given by the square root of k over m. Okay, so I can make k over m as a subject of formula. I can square both sides. Now k over m will be equal to w squared, meaning that at this point I can replace it with what? I can replace it with negative w squared times a, which is the same as negative a times w squared. So that's why I said from the formula just get this part only. That is the maximum acceleration. So if I go ahead and say the maximum acceleration is given by negative a w squared, let's see, the amplitude is 4, this is pi, but we square it. So what acceleration are we going to find? That should be, I'm starting with the acceleration before the speed, so it will be negative 4 times pi squared, that is negative 39, negative 39.48 meters per second squared. That is the maximum acceleration. To find the maximum speed, again, if I take you back the formula that we used for us to find the maximum speed, you realize that just getting this, okay, just getting a times w is the maximum acceleration. So in this case, if you want, you can ignore the negative. That's not a problem. Okay, yeah, you can ignore the negative, it's fine. And then what we're going to have, even for the acceleration, you can just get 8 times w squared, and the answer will be 39.48. But you can do any, there is no problem. So now what is happening? A is 4, w is pi. So the answer that we should find, it should be 12 times, or 12.57 meters per second. That is the maximum speed. So V max, that's the answer. Okay, now let's go to part E. Part E is saying find the displacement of the object between t is equal to 0 and t is equal to 1. So this question is not that much complicated, but we just have to understand a few concepts. For example, the first concept that I want you guys to be familiar with, we want to find the change in x, because we've got 2 time. So the first thing I'm going to find time, the displacement, this when t was equal to what? Let me start with 1. Okay, I can start with 1. So now it's going to be the displacement as t is equal to 1 minus as t is equal to as x is equal to 0, like that. So let's first find that. So now from the formula that we have been given for cos, we have, so when there is 1, meaning it's going to be like this. And we found this, remember? We found that to be negative 2.82 meters. Then we also find when there is 0, so it will be 4 cos pi times 0, it will be 0 plus this. So it will be 4 cos pi over 4, because this is going to give me 0. So 0 plus pi over 4 is pi over 4. So this should give me 2.1, okay, meters. Now the change in x will be equal to negative 2.82 minus 2.1. So the answer should be negative 4.92 meters. So that's the displacement of the object between t is equal to 0 and t is equal to 1 seconds. So that is it for question 1. So now let us look at question 2, which is saying a 200 grams block is attached to a horizontal spring and executes simple harmonic motion with a period of 0.25 seconds. If the total energy of the system is 2.00 joules, find the force constant of the spring, but B, the amplitude of the motion. Now, I want you guys to understand one thing. According to the data that we have got the mass, that is 200 grams, so we need to divide it by 1000 for us to get it in what? For us to get it in, so it's going to be 0.2 kgs. What else do we have? The amplitude or the period. The period is 0.250 seconds. Now, the moment we have heard that we have been given the mass and the period, and our goal is to find the k. Remember, there are those formulas which I want you guys to remember. There is the period is given by 2 pi times the square root of mass, okay, divided by the k. Then again, there is another formula for frequency. Frequency is 1 over 2 pi times the square root of it will be the opposite now. It should be k over m. So these formulas, I believe they gave you, but there is a certain topic I was explaining. If you manage to watch my videos, I explained where these formulas are coming from. Okay? So it's very important for you to know these formulas, because we have the period and we have the mass, and our goal is to find what? Our goal is to find the k value. So I can use that formula. There is no problem. Okay? So now what I'm going to do here is I'm going to use this formula for me to find k. So what I would do is I have to make k as a subject of formula. So what we'll do, we'll square both sides. So this will be t squared is equal to, this will be 2 pi squared is going to be 4 pi squared, then this is going to be m over k, because these 2 and the square root have cancelled. So again, these 2 affect everything here. So now we cross multiply, we have t squared times k is equal to 4 pi squared times m. Then we divide it by t squared, even here t squared. So k will be equal to 4 pi squared m divided by t squared. Let's try to plug in the values. Okay, so the k value is 4 pi squared, the mass is 0.2. Okay, I divide this by the period 0.25 squared. So the K value will be 4 times pi. Now pi has to be squared, times 0.2. Okay, the answer I'm getting is 7.89568. So I'll divide direct by 0.25, then I square it. So I'm getting 126.33. Okay, so let me punch again. So 4 times pi squared times 0.2, and then this answer I divide it by 0.250 squared. Yes, the same one. So it's 160 or 126.33. So the spring constant is always in Newton per meter. So that is the force constant. Now, after finding the force constant, how can we find the amplitude? To find the amplitude, remember, we have been told that the total energy, that is the mechanical energy, so the total energy is given by E, which is the mechanical energy, is given by half Ka squared. So our goal is to find the amplitude. So to find the amplitude, we just want to make the amplitude as a subject of formula. Okay, to get rid of the fraction, just divide it by 2 everywhere. So it will be 2E is equal to Ka squared. Divide both sides by K, here by K. Therefore, A squared will be equal to 2E divided by K. Now, we square root both sides, and A will be equal to the root of 2E divided by K. Let's plug in the values. A will be equal to the root of 2 times what is E? E is 2. Divide this by what is K? K is 126.33. So the amplitude will now be equal to 2 times 2 is 4. So 4 divided by 126.33. Now the square root of that number, I'm getting 0.1779 meters. So I can round it off and say the amplitude is 0.18 meters. So that is the answer. So that is it for question 2. Let's dive into question 3. So the question 3 is saying a particle moving along the x-axis in simple harmonic motion starts from the equilibrium position, the origin at t is equal to 0, and moves to the right. The amplitude of its motion is 2 centimeters, and the frequency is 1.5 hertz. Show that the position of this particle is given by this. So here we're just showing, and remember guys that the position is given by x as a function of time, is given by the amplitude sine the w times t, okay, plus phi. So if phi is 0, in this case phi is 0, so this is not going to be considered. We'll say as a function of time we'll follow this. So you are not going to include phi in that case. Now from the question here, we have been told that the frequency, what else don't we have here? We don't have what? Let's see. So we have the amplitude. We have the amplitude as 2.00 centimeters. Then again, we do not have W. But remember, from question 1, I told you guys that W is given by 2 pi f. So let's now go ahead and make and now find what? W. So W will be equal to 2 pi times the frequency is 1.5. So what I'm going to do, since the formula I want to show here there is pi, I'm not going to multiply pi. I'm just going to multiply 2 times 1.5. So 2 times 1.5, it is 3 pi. Then now I can go ahead and plug in the values as a function of time. Okay, A is 2.00 centimeters. I put them in the brackets, sine, then W now is 3 pi, but times T, like that. So I can clearly see that this is what I have here, hence shown. So let's talk about question 5, which is saying an automobile having a mass of 1000 kg is driven into a brick wall in a safety test. The bumper behaves like a spring of force constant 5.00 times 10 to the power 6 Newton per meter and compresses 3.16 centimeters as the car is brought to rest. What was the speed of the car before impact, assuming that no mechanical energy is lost during the impact or during impact with the wall? So here, if no energy was lost, I want you to understand one thing. An automobile having a mass of 1000 kg is driven into a brick wall in a safety test. The bumper behaves like a simple, like a spring of force constant 5.00 times 10 to the power 6 Newton per meter and compresses 3.16 centimeters as the car is brought to rest. So meaning that if energy was not lost, meaning that as it was moving, it had kinetic energy. So this is the conservation of energy, conservative of forces. So as it was moving, when something is moving, before it was brought to rest, it had kinetic energy. No energy was being lost. The time it reached, or the time it was brought to rest, at that point it had the elastic potential energy. Kinetic energy is given by half mv squared. Elastic potential energy is given by half kx squared. Now, I want you to understand one thing again here. Okay? So, I can cancel half and I will end up having mv squared is equal to kx squared. The question is, what was the speed of the car before impact? The way it was moving, what was the speed of the car before it was brought to rest? Now I have all the information. It was compressed. X is now 3.16 centimeters. In meters now we divide that by 100. That is my X value. So 3.16 divided by 100. That is 0.0316 meters. What else? The K value we have. What is the K value? 5.0 times 10 to the power 6. What else? We have the mass, 1000 kgs. Now, we want the velocity. Divide both sides by m, here m. V squared will be equal to k over m times x squared. To make v as a subject of formula, we'll get the square root both sides. So v will be equal to the square root of k over m times x squared. If I want, I can use this formula. I'll end up having the same answer. Or I can use this formula. I can say the square root of k over m, then x can be outside, meaning the square and this has been cancelled. Okay? So you can use any of the two, you end up having the same answer. So for this one, I'm going to use this one, the second one. V is equal to, the k value is 5.0 times 10 raised to the power 6. I divide that by the mass, which is 1000. Then times x value is this. So since I don't have space there, so V will be equal to 5.00 exponent 6 Okay, divide that by 1000. The answer I get a square root. The answer I'm getting now, do times 0.0316. Okay, so I'm getting velocity 2.23 4 meters per second. So now what you are going to follow here, all these things were in 2 decimal places, so I'll leave the answer in 2 decimal places. 2.23 meters per second. That's the velocity before the impact. Okay, so that is it for question 5.